Good morning and once again welcome to my YouTube channel whereby we'll be talking of solving mathematics. My channel is Pearson and Excel International Maths by Mr. Kamotho, and I'll be talking about pure mathematics book 3, and we have been dealing with chapter 5, and I want us to explain something to do with example 4. I want us to look at example 4, and this is on page 106. In example 4, we are told to sketch the graph of the following equation and give the coordinates of any points where the graphs cross the x-axis, and the first graph is y is equals to e raised to power 2x. And when we talk about y is equals to e raised to power 2x, we have known from the beginning that when the power is 0, then the graph passes through point 0, 1. And when x is equals to 0, e raised to power 0 is 1. When x is a negative number, therefore y becomes a very small number. It approaches 0 because we are going to have 1 over a very big number, so it approaches 0. And when x is going to be a positive number, again it's going to be something which is also big, positive number. So our function or our graph looks like this. So if you compare this with the graph of y is equals to, compare this with the graph of y is equals to e raised to power x, you realize that when x is positive, it is not going to be as big as this particular. So it's going to be having something like this. But when x is negative, so 1 over a small number gives us a big number. So on this other side is going to be bigger, giving the values of y which are larger than those of e raised to power 2x. So this is y is equals to e raised to power 2x, and this is y is equals to e raised to power x. On the other side, this is y is equals to e raised to power 2x, and of course this is y is equals to ex. And that is just like how you should be able to sketch the graph of y is equals to e raised to power 2x. And if you look at part B talks of y is equals to 10 e raised to power minus x. And there are two things happening here. Of course, you learned in the previous video that when e is raised to power negative x, the value of y becomes big, and I'll explain again why this is the case. But it is of importance to note what will y be when x is going to be equals to 0. So e raised to power 0 is 1, and 1 times 10 is obviously going to give us value of 10. So when x is a positive number, so we are going to have 1 over e raised to power a positive number. So as x increases, 1 over a big number becomes small, and that small number approaching 0, actually 0 times 10 will approach 0. But at this particular point I want us to talk about. So the graph looks like this. And when x, let me just explain why y is a greater value here. When x is, let's say, a negative number, so e raised to power minus a negative, so it remains e raised to power positive number. That means a big number. When it is multiplied by 10, then becomes a big number. This is as opposed to the graph of y is equals to the graph of y. This is 10 and this is 1. This is the graph of y is equals to 10 e raised to power minus x, and this is the graph of y is equals to e raised to power negative x. But it is part C we must take great care of, and it's talking about y is equal to 3 plus 4 e raised to power a half x. And I want us to ask a few questions. When x is 0, when x is going to be 0, y is going to be 3 plus 4 times 1, which is 4, and it's going to be 7. When x is 0, so we are going to have a graph that cuts the y-axis. You're going to have the graph that cuts the y-axis at 7. Let 7 be there. What happens when x is going to be a very small number? A very small number, which means very extreme to the negative side. So e raised to power a very big negative number is 1 over a very big number. That means it's approaching 0. And when it is approaching 0, 0 times 4 is 0. Of course, plus 3 is 3. So you will realize that there is no way that the value of y will go below 3, because as much as this whole term approaches 0, 0 plus 3 is going to, so we are going to have an asymptote here along the line y is equals to 3. And the graph looks like that. This is the graph of y is equals to 3 plus 4 e raised to power a half x, and there we go. That's exactly what we have. It is important to realize that in this graph, this is the graph of the form y is equals to e raised to power ax plus b, of course everything plus c. This compares very well. It compares to 4c above this one. Why does it compare? With calculations, we will realize that the asymptote, with calculation, we realize that the asymptote is y is equals to c. Why is y is equal to c? Because when the other term that is having the exponential is approaching 0, of course 0 plus the constant remains the constant, and that is why the asymptote will always remain the constant. At the same time, you will talk about the y-intercept. What is the y-intercept in such a graph? The y-intercept is where the graph cuts the y-axis. And it follows that when y is equals to a, or rather e raised to power ax plus b plus c, according to the laws of indices, this part talks about e raised to power ax multiplied by e raised to power b. This is what we are having. But when the exponential is having x that is approaching 0, when x is 0, when x is equals to 0, then we talk of e raised to power 0, which is 1, times e raised to power b, which is e raised to power b. That being the exponential part, then we just have to have the constant here. So it can also be explained if we let x to be equals to 0 here. If we let x to be equals to 0 here, then we are talking about e raised to power 0 plus b e raised to power 0 plus b plus c, which is eventually e raised to power b plus c. So the y-intercept generally would be where this particular point, this is the asymptote, y is equals to c, and this is the y-intercept, and we say, of course, x is 0 there, but the value of y is e raised to power b plus c. Those are the coordinates of the y-intercept. And what graph is this? Y is equals to e raised to power ax plus b, of course, plus c. And that is just like it. It's a general approach. We will see it in some other videos in the future, but generally we have been able to sketch the graphs of the three functions as expressed in example 4 from part A all the way to part C. Again, please subscribe to my YouTube channel, share, and of course like, so that we can work together. All right.